So the 10,000-foot overview of my research involves basically the design and synthesis of macromolecules. More specifically, these are called polymers. And polymers exist on our daily life in a variety of ways, everything from the functions within our own body, to the materials that we come across in nature, to the synthetic materials that we come across in our more convenient daily lives, such as plastics. And so we strive to understand new methodologies to create new functional materials under the umbrella of this type of macromolecular structure, with the goal of trying to solve some societal issues that are arising either in areas of plastic pollution or recycling, or in areas of energy storage, and even towards maybe biomimetic functional type materials as well. Really down at the fundamental level, the goals of our research, we like to try and uncover new methodologies to make monomers, which are the chemical precursor of polymers. We try to find new ways to turn stubborn monomers, ones that don't necessarily easily make new polymers, we try to get them to make polymers. And by doing so, we unlock kind of a large variety of new material properties that have been largely absent or understudied to this point. And what we've been discovering is that you get a very interesting new subset of properties by being able to take some of these classically undervalued monomers and finding new ways to get them to turn into materials. So we have three main thrusts in the group right now. One, as I've said earlier, is on the biomimetic or bio-inspired type of systems. This has a lot to do with the architecture of the macromolecule. So you can try and create new architectures, and you can try and toy with the chemistry as well, and combine these two things serve to provide a large majority of the properties of the polymers that we come across. The other area of research that we're working in is geared towards alternative materials for membranes and fuel cell technology. And so we've been able to take some of these stubborn monomers, as I described earlier, and turn them into some really fascinating materials that transport protons very well. Lastly, an area of research that we're interested in is just basic fundamental copolymerization reactivity. We know very little about how certain types of monomers will copolymerize with one another. And if you can understand how they sequence themselves within the macromolecule, you understand then how the properties of that macromolecule are affected by the sequence of the co-monomer units within the system. And that's truly powerful for unlocking structure-property relationships and understanding how we can make futuristic materials for a variety of applications. We hang our hats in the areas of organic chemistry because we like to make our own new materials, but once we've made those, we have to find out the properties of these materials. And so we traverse from organic synthesis to molecular characterizations to understand what we made. Then we move forward with some thermal properties, maybe even some basic engineering principles like mechanical testing and viscoelastic behavior to truly elucidate from cradle to properties, what have we made and is it interesting? And how can we tune the chemistry again to maybe tune the properties that we want specifically?